this session, we will discuss about the conversion of decimal to binary, octal to binary, and hexadecimal to binary. In the last videos, we have seen the conversion of binary, octal, and hexadecimal to decimal number system. So, if you are not clear in the conversion of other number system to decimal number system, just go to the playlist and watch the video. In this session, we will discuss about the decimal, octal, and hexadecimal number system to binary number system. So first, we will see the decimal to binary conversion. So for that, we will take an example. Let the example be a decimal number. Suppose the number be 31 to the base 10 or to the base d. We can write 31 to the base 10 or 31 to the base d or 31 to the base 10. So it denotes that 31 is a decimal number. So in order to convert this decimal number to binary number system, we are going to use successive division by 2 method. Division by 2 method. So in order to convert decimal to binary, we are going to use division by 2 method. So we will see how to do it. So first write 31 and we are going to divide it by 2. So 1 into 2 is 2 and here it is 3, so the remainder is 1. So 1 times 2 is 2, we have 3 here, so the remainder is 1. That 1 plus 1 is 11. So 2 will go 5 times for 11, that is 2 into 5 is 10 and remainder is 1. Or we can say 2 into 15 is 30, remainder 1. It's just a normal division. So we are writing the remainder separately. We are writing the remainder here separately. So this is the remainder. After division by 2, after dividing 31 by 2, the remainder, what the remainder we are getting, we are writing separately. We will get either 0 or 1. If we divide a number by 2, we will get only 2 remainder, either 0 or 1. If it is an odd number, we will get remainder 1. If it is an even number, we will get the remainder 0. So again, we are going to divide this 15 by 2. So we will get 7, isn't it? 7 into 2 is 14 and the remainder is 1. Again, we are going to divide by 2. We get 3. 3 into 2 is 6. Again, remainder 1. We are going to divide it again. That is 1 into 2 is 2. But here it is 3. So 1 into 2 is 2. So remainder is 1. So again, we are going to divide it by 2. So we cannot divide 1 by 2. So we are going to put 0. So 0 into 2 is 0. But here it is 1. So the remainder is 1. 0 into 2 is 0. So the remainder is 1. So it is better to complete till this step, till it reaches 0. Otherwise, it may create confusion when you write the binary number. So you'll get a sequence like this. Okay. The first one you got, the first remainder you got is the LSB. The first remainder you got will be the LSB. That means that is 1. The next one, the next remainder will be the next digit, that is also again 1. Again, the next remainder is the next digit, again it is 1. Again, the next remainder, it is 1, and finally the last remainder. So the last remainder is the MSB, and it is also 1. So the final answer, 31 to the base D is equal to 1, 1, 1, 1, 1 to the base B. So decimal 31 is 1, 1, 1, 1, 1 in binary. So we can see one more example. Consider 23.213 to the base D. That means it is a decimal number. We have to convert this to the binary number. So we want to find the corresponding binary number. Here we already know how to convert this 23 to the binary by using division by 2 method we have seen just now. So here there is a fractional part also. You can see this is the integer part and this is the fractional part. So in integer part we are using the division by 2 method to convert decimal to binary. The fractional part we are using multiplication by 2 method. So when a decimal number consisting of integer part and fractional part is given, in order to convert it to binary, the integer part we are using division by 2 method and the fractional part we are using multiplication by 2 method. So we will see how we are going to use it. So first we will see the division by 2 method. That means 23. So we have to divide by 2. That is 11. 11 2s are 22. Remainder is 1. Again we will divide by 2. 5. 5 2s are 10 and the remainder is 1. Again 2. 2 2s are 4 and the remainder is 1. Again 2. 1 2s are 2 and the remainder is 0. Again we will divide by 2. 0 2s are 0 and the remainder is 1. So we got the answer. That means the integer part 23 to the base D is equal to, how will we write? This is the MSB, isn't it? This is the MSB. So we will write 1, next number is 0, 1, 1, 1, and this last one is here. So we will write from bottom to top. So this is 23. So if you want to check, we can check 23. We will check 23. So you can see here decimal 23 means in binary it is 0 0 0 1 0 1 1. So first 30 we can omit it because there is no use of putting zeros on the left side. So the answer is 1 0 1 1 1. So that's our answer. You can see here 1 0 1 1 1. Decimal 23 is 1 0 1 1 1. Now we will see how to convert the fractional part. So the fractional part is 0.213. So fractional part we are going to do multiplication by 2 method. So 0.213 into 2 is equal to, we will get 6, 2 into 1 is 2, 2 into 2 is 4. That is 0.426. So So here we have to take the integer part. What we are getting in the integer part we want to take. Here it is 0. So we have to write it separately. Now again, this fractional part take here and again multiply it by 2. That means 0.426 into 2 is equal to, so we will use the calculator, 0.462 into 2 equal to 0.924, 0.924. So the answer is 0.924. So what should we write along the right side? Again, take, here we have taken this integer part, isn't it? So here also we are going to take this integer part. Integer part is 0. So take it and write it separately. Now again take this fractional part and multiply by 2. That is 0.924 into 2. That is equal to 0.924 into 2, 1.848. So that is 1.848. So now we have to take this 1 here. So now again we have to take the fractional part, that is 0.848. 0.848 into 2 is equal to 0.848 into 2 is equal to 1.696. That is 1.696. So again take this one here. So we will stop this multiplication. We will stop this multiplication once we will get here like 1.000. After multiplying by 2 at certain time, sometimes we will get after 2 or 3 steps, sometimes it will go to 9 or 10 steps, we will get as 1.000. If all the fractional part are 0, then we can stop. Till then we will continuously do these steps. So but in exam, if this is not going to happen, if all the fractional part is not going to become 0 in 3 or 4 steps, in exams they will usually mention up to 3 fractional places or up to 4 fractional places. Here we have calculated 4 fractional places, 1, 2, 3 and 4 fractional places. So the final answer is 23.213 to the base d is equal to, so we have this binary for 23, so that is 10111 point, and we have just found the binary for 213. So in 213, when we have found this 0011, so we have to write it from top to bottom. We have to write it from top to bottom. In the division by 2 method, we are first writing the bottom part. We are first writing the bottom part. We are going to the top words. 1 0 1 1 1. First we are writing this one. Then we are moving to top. But in fractional part, first we have to write the topmost bit. Then we have to move to S bottom. So that is 0 0 1 1. This 0, this 0, this 1 and this 1 from top to bottom. So remember that. So this is the final answer. So division by 2, we have to go from bottom to top, and for multiplication we have to go from top to bottom. The order you have to keep it very clear. So this is how we convert decimal to binary. So we have covered both the integer part and also the fractional